Hello, everybody. Today we're going to talk about factoring, specifically factoring quadratics. So there's a couple differences with the different types of quadratics and where the numbers are. So we're going to look at a few of those. So we have this problem here, y squared plus 7y plus 12. And like some of the problems we've had before when we were multiplying polynomials, we would make our apartment. And with our apartment, we would multiply certain terms in. We'd have this term, and we'd have this term, we'd have this term, and we'd have another term here. We'd have 4 different terms, and we'd multiply them together to make an answer here. We'd make an answer here, and these two were a little bit easier because it was this one times the blue times the red to make this purple one here, and the orange times the green to make this yellow one here. But these those two boxes were a little bit different and specific because those ones would be orange and blue, green and red, and they would make a term that we could combine, and they'd be like terms. And so when we'd finished over here, we'd write them all down, and we'd have all these terms that we need to combine. And when we combine them all, or we couldn't combine them all, but we'd write them all down in one form, and then we'd combine the middle 2 terms to make one term at the end. And this would be our answer. 3 terms here. Well, if you look over this problem, it has 3 terms. And we're starting at the answer, and we've got to work our way backwards to find out what these 2 binomials were that we multiplied in the beginning to get us down here. So if you look at this, we can already set up our answer here, and we can say we have y squared, we have 7y, and that's positive, and then we have positive 12. Well, if I go backwards another step, I can say this is y squared, and this is positive 12. But positive 7y, I'm not sure how I'm going to break that up. And I don't know if I need to make any negative, if they both should be negative, or they both should be positive. So we're going to kind of look through some of this. And this is the step that makes it a kind of a challenge. Okay, so we know where y squared is going to go. We know where 12 is going to go. It's 7y that we need to figure out. So there's a way to do this, and one way is to make a table. And with our table, we need to find out what 2 numbers will add to 7, but at the same time also multiply to 12. You have 3 different terms here, and if we label them A, B, and C, then we can do A times C and we can also do B. So we need these 2 numbers to multiply to this. On this one, A is just a 1, so A times C is 12, and B is 7. So we need to find something that multiplies to 12 and adds to 7. So let's look through here. We have 7, we have 12. And I'm going to make 2 more columns here at the front, and these are going to be the 2 numbers that we're trying, P and Q. All right, so let's try some of these out. What are 2 numbers that multiply to 12? Well, I know that 2 and 6 multiply to 12. So 2 times 6 makes 12, check. But does 2 plus 6 make 7? No, that doesn't work. If I wanted to, I could try maybe negative versions, -2, -6, Negative 2 times negative 6 makes positive 12. Check. But it doesn't make 7. I could keep going. I could say, you know what? I don't think the negatives are going to work. All my answers are going to be all these positive numbers, so I don't think it'll ever work because this made negative. This will have a negative answer when I add them, and I don't want any negative answers. I want all positive. So let's try another one. Let's try 3 and 4. 3 and 4 make 12. 3 times 4 is 12, and 3 plus 4 is 7. I can keep going with my list if I wanted to with negatives with other numbers, but I don't want to. I want to stop here, okay? Because this is my answer, 3 times 4. So now I know over here that I'm going to have 3y and 4y, and they're both positive. So now I know these middle terms that go in here. And for us, what that means specifically for our table, we can start adding these into those places and keep going backwards to find these. But when your letter A, when that first coefficient, when there's not a number in front of that y squared, then these two actually end up being our answers as well, 3 and 4. We know that it's going to be y plus 3 and y plus 4. Those will be our two answers. From our table with 3 and 4, it'll work in here, and we're done. When we have a different number in front of the y squared, we're going to have more steps to do. But this one, we can finish there. And if I look at my explanation and double check my work, you can see they made a table as well. Y plus 3 and y plus 4. At least I think that's a plus sign. Yep. All right. So let's go to this one next. So now on this one, I have a number in front of here. So that means it's going to be a little bit different. So let's see. A times C. In this case, it's 2 times 5. 2 times 5. That makes 10. All right. And my letter B is negative 7. All right. So let's make a table. So if we have PQ, 10, and negative 7, let's pick some numbers that multiply to 10 and add to negative 7. So P and Q for 10, we can start with 1 and 10. 1 times 10 makes 10. That's good. 1 plus 10 makes 11, and that's a no. All right. Let's try another one. This is a negative number, so maybe we want to try one that's negative. Maybe if 1 is negative and 10 is positive. Oh, that won't make 10. Maybe we'll make them both negative. Negative times a negative makes a positive. That makes positive 10. And this makes a negative 11, so nope. Let's try another one. Let's try 2 and 5. Now, what I noticed on that last row is that I got my answer 10, but I also got a negative answer here. I'm looking for a negative 7. So I'm not going to try any more groups of the positives. I'm going to only try them when they're both negative. Negative 2, negative 5. That makes positive 10. If I add those, that also makes negative 7. So now we found our answer here. And we know that we're going to have 2y squared. 2y squared. We know we're going to have plus 5, plus 5. And in the middle here is where our green came from. Okay, and so we're going to have negative 2y minus 5y. So here's our big long polynomial. This is our answer, but we want to factor it more. All right. we've started factoring it here, but we got to keep going all the way. So what we can do from here is we can take our group and split it into two and factor by grouping, like we've done on the last assignment. So when there isn't a number in front, we know that these two numbers are going to be our answers in our factors. And we can just say our variable minus 2, variable minus 5. So in this case, y minus 2, y minus 5, and be done. But because there's this number 2 in front here, this number in front of it, it means we got to do an extra step. We got to factor by grouping. So I'm going to look at this group and take some things out that match. So I could take out a 2 on both of these and a y. So let's see. Out of here and out of here. First one, I could take a 2y out. So I'm going to do that. 2y. And on the inside, I'm going to have, let's see, that'd be y and minus 1. Y minus 1. All right, let's look at this next one. And we have out of here, we have negative 5, we have 5. So I can take a 5 out. But when I take a 5 out, what I'm left with is negative y plus 1. I don't want negative y plus 1. I want y minus 1. So let's make this 5 a negative. And then if I take out a negative 5, it should match up. Negative 5y, negative 5 comes out. Positive 5 minus or divided by negative 5 will give us a negative 1. And so now our final answer that I'm going to put in purple, we have y minus 1 and our other term is 2y minus 5. 2y minus 5. Y minus 1, 2y minus 5. And if I check our explanation, you can see they made a table as well, and they got, if I can show it, y minus 1, 2y minus 5. All right, same thing that we got here. So I'm going to do one more problem that's very similar to this one, but numbers in different negatives have switched around. So we have 3x squared plus 16x plus 20. So I know that 3 times 20 is going to be 60. And I know that my b is 16. So I needed something that multiplies to 60 and adds to 16. So let's make our table here. So multiplying to 60, adding to 16. They're all positive, so that makes things nice. It means on any of these rows, I can put negative numbers that work to make positive 60 when I multiply, but not when I'm going to try to get positive 16 and positive 60. So in all these rows, I'm not going to try any negative numbers, which should cut some time off of this problem. So what are two things that make 60? Well, I know that 2 and 30 make 60. Now, some of you in your head might be thinking, Mr. Copeland, yes, that makes 60, but there's no way that you can add those to make 16. And you're right, I'm going to get 32. If you already can tell in your head it's not a good option, you don't have to write it down. You can keep working on ones that you might think work. And this table that you are making, it's totally on you. I'm just making it to kind of go through my thought process and make sure that I get two things that multiply to 60 that also add to 16. So let's try, I can do 4 and 15. 4 times 15 makes 60, but that makes 19. So that's a no. So I'm going to keep going. 5 and 12 makes 60, and that makes 17. I'm getting closer, 32, 19, 17. I'm getting a lot better with my guesses, but I'm still not there yet. But let's try this. Let's try 6 and 10. That makes 60, and if we add them, we get 16. All right, so I got my answers here. So now I know that I have 3x squared and plus 20, and this positive 16x I'm going to get with these two terms. So 3x squared plus 20, and now I have plus 6x plus 10x. So let's group these together and factor things out. So what can come out of this first one and what can come out of this second one? Well, if I look at this first one, they both have an x, so I can take an x out. And they both have 3. 3 can come out of the first one, and 6 divided by 3 is 2. So I'm going to have x plus 2. And if I look back on the right, they both have 10s. I can take a 10 out, and it should be a positive 10 that comes out. And 10 divided by, or 20 divided by 10 will be 2. So should have x plus 2 again. These should match every time we do this. And if they're not matched, you might have to switch a negative sign or look back if you did your math correctly. But our final answer should be 3x plus 10 that we got from our light blue here. And then our orange ones, x plus 2. If I look at my explanation, you can see the table they made was a lot bigger than mine. They added all those negative numbers in there, but because we saw that they were positive, we skipped that. So ours went a lot faster. And their answer down here was x plus 2, and my table's in the way, 3x plus 10. Theirs is a different order than ours, but mathematically that's the same. All right, there's 2 more problem types I want to show, and these ones are going to get a little bit quicker because they just have a couple extra things in them that I want to show. So with this problem, this one has a leading coefficient that's negative, okay? So it has a negative 2 here. We worked on one that had 2 or the one that had, what was the last one? I don't remember. But they had different numbers, but this is the first one that's been negative. So this one being negative, we can do something that actually, instead of changing the problem and everything we do when we got more negatives in it and everything's different, we can just take the negative out first. Let's just factor a negative 1 out of everything. So if I take out a negative 1, then on the inside, I'll have, well, negative 2v squared becomes positive 2v squared. I'm going to divide all these by negative 1, which changes their sign. So instead of positive 11v, now I'm going to have negative 11v. Instead of positive 21, now I'll have negative 21. And so now I can factor this just the same way as we've been factoring all these other problems in this video. And then eventually I'll have a negative in 2 factors. And if you look at the explanation here, without me making you watch all of this again, we can factor and we get an answer with a negative out front and then these 2 on the inside. And if you can see this step here, let me use another color to make it obvious. This step here is what we got when we did it ourselves. All right, same thing there. And it gave us an answer after we factor this one out into the 2 terms. That negative sign is still out front. So on these ones, you still have to factor it all the way. I'm not done with my problem, but I stopped early because I don't want to make you watch me do it all over again. All you have to do, if you see a negative in front, take the negative out first, change the signs on the inside, and then solve the problem from there. Now this next problem is going to be kind of similar to that. We're going to look and see, and if there's something that we can take out first, then we can do that, and the rest of the problem will stay the same. So if you notice the terms here, we have a 3 in front. This one is 30, and that's a multiple of 3, and 72, which is also a multiple of 3. So instead of doing all this problem with everything multiplied by 3, we can take the 3 out and make it a little bit easier for ourselves. So we're going to take a 3 out. And if we wanted to do this problem, we could do it all the way. It's just going to make the numbers bigger and a little bit harder, especially when you're looking for 3 times negative 72 and adding to 30. Those numbers are going to be a lot bigger. If we take the 3 out, then we'll have w squared plus 10w, and I'm going to feel like Dora the Explorer here. Does anyone know what negative 72 divided by 3 is? Wait. Good job, everybody. It's 24. I definitely didn't pause and use my calculator. I knew it. So from here, if we keep factoring, we're going to have a lot smaller numbers, because now we're going to be looking for numbers that multiply to negative 24 and add to 10, a lot smaller. But still, mathematically, we'll do the same thing. If I look at my explanation, they did the same thing. They took that 3 out, got what we got, and then they kept factoring here. And just like me, they didn't show all those other steps because they don't want to hear my voice over and over and over again. And so now at the end, we have that 3 out front of our 2 factors. So this will finish this video. There's a couple different problem types that we did where you're factoring these, and there's some that have these extra cases where you can kind of take stuff out first and make it a little bit easier on yourself as you continue to go. So always look for those that first term, and it's something that can come out of all the terms. Get rid of it first, and then our answer will be a lot faster.